Okay, so we are doing part B of this question. Where did I put it? Yes, this question for CUM Limited. All right, we are calculating the internal rate of return for project 2. All right, so let me just bring this information here. All right, so as I said, the internal rate of return is just a continuation of the net present value technique. All right. With the internal rate of return, you want to have two net present values, one that is positive and one that is negative. All right. So for project 2, we did the first part. We got our first net present value. Colleagues, are we okay with this net present value technique where we are converting this money which we receive in the future into its present value? Then we add up. Any questions before I go to the second part of this? This first part was already done in part A. We got the net present value. So with the net internal rate of return, we're going to need to get a new net present value. So before I proceed, are there any questions on these tabulations here? Uh-huh. All right. As you can see in the question here, all right, this company is deciding which project they want to invest in. All right. So here we are focusing on project 2. Project 2 costs 65 million. And then after we pay that 65 million for project 2, these are the earnings we expect to receive, okay, from project 2. In year 1, we expect to receive 24 million. In year 2, we expect to make a loss of 3 million. In year 3, we expect to make a profit of 6 million. Then in year 3 again, we can sell this plant for 6 million. Okay, it's like this plant is useful for 3 years. So after 3 years, you can sell it for 6 million. So initially, in part A, we were calculating the net present value, which is basically this. Let me highlight these first columns, these first 4 columns of this table. Okay, we listed down our cash flows. Okay, from the information from the question. Year 0 is the first day of year 1. This 65 should represent it as a negative value. Why? Because it's money coming out of your pocket. Okay, colleagues, when you see brackets, just know it's a negative number. Okay, or maybe let me just put the negative signs there. So, Madam Liane, what's happening here is at first you need to convert this money that you're going to receive in the future, you need to convert it into today's value, into the present value. And how do we do that? Present value equals future value 1 plus R the power negative t. All right. Here, the future value is represented by the cash flows. Then this discount factor is represented by this 1 plus R to the power negative t. Discounting, colleagues, means converting a future value into a present value. Okay, when you hear discounting or a discount factor, just know that you're trying to convert money in the future into today's value. So the rate is already given in the question here. Okay, the cost of capital, basically, to get any of these projects, we need to borrow money. Now, that money we're borrowing is not for free. Okay, it's going to cost us. Okay, so that the cost of borrowing is this cost of capital, 25%. You're going to use it as your rate. So, as you can see here, since it's 25%, okay, you convert this 25% into a decimal. Okay, it becomes 0.25. So you have 1 plus 0.25 to the power negative t. When you add 1 plus 0.25, you get 1.25. This is this 1.25 to the power negative t here. All right, this is what we're going to be using to convert these future values into the present values. So in year 0, you put it as 1.25 to the power negative 0. You get 1. You multiply. Negative 65 times 1, you get negative 65. Year 1 is going to become 1.25 to the power negative 1. Okay, this t, this power negative t power, it's just following the years. So whatever year you're in, that's what t is going to be. All right, so year 1, 1.25 to the power negative 1, you get 0.8. The present value of this 24 million, 24 times 0.8, 19.2. And you repeat that process for year 2 and year 3. Is that okay, Madam Liana? Any questions? Okay. Okay. Then at the end, when you've converted this money in the future into its present value, you add up. Okay. Say negative 65 plus 19.2 plus negative 1.2 plus 3.02 plus 3.02. You get negative 41.576. Okay, so this is our first net present value. And colleagues, according to the net present value technique, how do we make our decision? What criteria do we use to make the decision for the net present value technique? Wonderful, sir. Thank you very much. Yes. If your net present value is negative, you reject your project. Negative represents losses or a loss. So you reject your project. Okay. Basically, what it's telling us is the money that you expect to earn, when you total it up, it's going to be less than what the project is costing. Okay. So if the money you make is less than what the project is costing, it means you're in a loss. They're supposed to make more money than what the project costed for that project to be viable. So the internal rate of return is just a continuation of this. Okay, the internal rate of return, these cash flows here, basically these cash flows, you are trying to get them in a percentage format. Remember, return represents the money you're getting in percentage form. So with the internal rate of return, it is just a continuation of the net present value technique. So if you understand the net present value technique, just remember the internal rate of return, just a repeat. Now, things you must consider once you're doing the internal rate of return. I'm going to write this down again, and you always need to remember this. If your first NPV, net present value, is negative, reduce discount factor or discount rate. Okay, because when you reduce your discount rate, you're likely to get a positive net present value. Just hold on for it. Okay, where was I? Yes, if your first net present value is negative, reduce your discount rate. By reducing your discount rate, you might get a positive net present value. Then, if your first net present value is positive, increase your discount rate. So, colleagues, you need to remember this. Okay. If you have enough time in the exam, maybe if you make a mistake, your net present value is negative, and by mistake you increase, you will see that you get another negative net present value. Then you know that, okay, I made a mistake by increasing. I need to reduce. But in the exam, again, there's no time for trial and error. You must get things right there and then. Isn't that correct, colleagues? In the exam, you must get things there and then correct. And there are no miracles in the exam. So please take note of this. Remember it. One way you can remember, if your first net present value is negative, negative means reducing, so reduce discount rate. First net present value is positive. Positive means increment, so increase your discount rate. Any questions before I move further? Okay. So in this case here, since our net present value, our first was negative, so we need to reduce our discount rate. Okay. So it's up to you to choose when you're reducing. Okay. Since our initial discount rate was 25%, which was the cost of capital, so we have to our new discount rate must be lower than 25%. Okay, so this is where the trial and error part comes in. Okay, you try 20%. If you see it gives you still a negative net present value, lower it again. You try 15%, it still gives you a negative. It means continue lowering. Okay, so for this question, we reached 1%. Okay, never use 0%. Okay, end on 1%. Okay. So the new discount rate that we're using is 1%. Okay. So our discount factor, since the rate is 1%, so it's going to be 1 plus 0.01 to the power negative t. And 1.01, 1 plus 1.01, you get 1.01 to the power negative t. This is our new discount factor. Any questions, colleagues, before I continue? All right. So year 0 is going to be 1.1 to the power negative 0. Colleagues, you can also use tables for this, okay? I will show you how to use the tables. So that the tables, they only end at 20%. So if in the question, the rate is above 20%, then you have to use the manual way. But if it's less, it's 20% or less than, you can use the tables, okay? So 1.01 to the power negative 0, that is 1, okay? To get the present value, we're still multiplying these cash flows. Now I'm multiplying it with these discount factors. Okay, so negative 65 times 1 gives you negative 65. In year 1, our discount factor will be 1.01 to the power negative 1. 1.01 to the power negative 1, 0.99. So you're going to multiply 24 by 0.99, you get 23.76. Year 2, our discount factor 1.01 to the power negative 2, we get 0.98. This 0.98, we're multiplying it with negative 3, we get negative 2.94. Okay. Year 3, 1.01 to the power negative 3, that gives us 0.971. Multiply that 0.971 times 6, you get 5.826. Then again in year 3, remember, you can sell this plant for 6 million. So if we wanted, would have combined this 6 million for the amount we get from selling the plant plus the profit we make in year 3. We could have added them up together, okay? Or we can also represent it like this. Either way will be okay. Okay, so since that's how much you can get for when you sell the plant in year 3, so that's why we're going to still use again our discount factor for year 3. Do not put year 4. No, it's still year 3. Okay, so 1.01 to the power negative 3.971. Multiply that by 6, 5.826. When we total up our present values, let's get our calculators to verify these figures, okay, colleagues? We need to verify. Okay, maybe I made a mistake somewhere. I mistyped something. And you just do copy and paste, and you're surprised you're hammering a 50%, maybe it's because of the calculations. So negative 65 plus 23.76 plus negative 2.94 plus 5.826 plus 5.826, we get negative 35.28. Let's confirm with our calculators. Are we all getting negative 35.28? Let us confirm. Are we all getting that value? Mr. Mpasa, are you also getting this value? Madam Diana, Madam Liana, Madam Evelyn, are we all getting negative 35.528? Or none of us have calculators? 32, you got 32? Oh, thank you, colleagues. Thank you. Even this side, it's negative 41.576. Because remember, this video is your video of reference. So let's make sure we avoid confusion by putting wrong numbers. Okay, this one's negative 45.76. Okay. So, as we've seen, in this case, we failed to get a positive net present value, which is an indication that this project should be rejected, because as you're going to see when we calculate the return, when we put it in percentage format, we're going to get a very low return. Very, very, very low. Okay. So once you've used the last discount rate, which is 1%, and you still get a negative one, you still continue with the process. So the next part is the formula. This one here. All right. This is the formula we're going to use. And as I said, this formula will be given to you. It may not be given to you in this format, but in other books you see they use A and B. Other books they use other symbols, okay, but the concept is the same. Okay. So for this formula, colleagues, you just need four figures from the table. The first figure is this L%. This L% represents your lower discount rate. Okay. L%, your lower discount rate. In this case, from our table, our lower discount rate was 1%. Okay, remember we've used two discount rates. 25 and 1%. So our lower discount rate is 1%. The next figure that we need is our higher discount rate, H%, which is 25%. Any questions, colleagues, before I move further? You can write on your papers L% lower discount rate, H% higher discount rate. Okay. The next figure we need is our net present value with the lower discount rate. Okay. So the net present value that we got with our lower discount rate, which was 1%, was negative 32.528. Okay, that's our lower discount, our net present value with the lower discount rate. Then you also get your net present value with the higher discount rate. NPV H%. Okay. And we got this negative 41.576. So before I proceed further, colleagues, are we okay with these four figures that we need to acquire? Any questions? So it's just a matter of substitution now in the formula. Where you see L%, you replace it with 1%. Where you see NPV L%, net present value with the lower discount factor, here negative 32.528. This NPV L% again, negative 32.528, minus NPV H%, the net present value with the higher discount rate, negative 41.576. Open brackets, H%, 25%, minus L%, 1%. Okay. Then it's just a matter of tabulating now. Okay. You're going to say negative 35.528 minus negative 41.576. Let's see what value I get, because I used 35 last time. 32.528. Yes, you get 9.048. Okay, 9.048. Okay. Then here in the brackets, 25 minus 1, that is 24%. Okay. Then you're going to say negative 32.528 divided by 9.048. So negative 32.528 divided by 9.048, you get negative 3.595. After I've divided this fraction, multiplied with the number, so negative 3.595 multiplied by 24 we're going to get negative 86.28%. Then you say negative, you say 1% plus negative 86.28, you get negative 85.281%. So this is the internal rate of return, or basically this is your return from the project. Okay, if you invest in project B, this was for, yeah, project B, this will be your return. Okay, those cash flows represent a return of negative 85.281%. Now, any questions before we make the decision? Okay, so the way you make your decisions like this, if your internal rate of return, your IRR is less than the cost of capital, you reject your project. But if your IRR is greater than your cost of capital, accept the project. Okay, here basically comparing your return versus your cost of borrowing. So if your return is greater than the cost of borrowing, then that's a good project to invest in. But if your return from your project is less than the cost of borrowing, then that's not a good project to invest in. So here, our return of negative 85.281 is way below 25%. Way below. It would have even been better at least if it was a positive value, but here it's a negative value. So, since our IRR is less than the cost of capital, we reject the project. Any questions?